This lesson explores two specific properties of congruent triangles. We're going to talk about hypotenuse leg, and then we're going to talk about something called CPCTC, and it's fun to say, not hard to understand. Let's talk about hypotenuse leg first. How do you prove triangles congruent using it? Here's the statement. If the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and one leg of another triangle, then the two triangles are congruent. Now you'll notice I only marked two pieces as congruent because we know right angles are congruent. We still have three pieces that are congruent. So we're staying with the rule that says you've got to have three pieces of congruent information. So now we're going to talk about applying a couple of other properties. So let's look at, I'm going to color it in because I can. Remember the reflexive property. It says anything is congruent to itself. Okay, so is this a right triangle? Yes. Triangle LKN is a right triangle. Triangle JKN is a right triangle. So, yes. But is the hypotenuse congruent and is a leg congruent? Now let's look. This is our given information. So with our given information, KN is, well, that's reflexive property. KN is congruent to KN. That's not given information. That's reflexive, my bad. So what we have to do, is it a right triangle? Yes. Looking at these two triangles, is the hypotenuse? We don't know. We don't know if that's congruent because we don't have anything. The hypotenuse is LN and JN. We do not know if they're congruent. The leg, a leg is congruent. KN is congruent to KN. So we don't know if those two triangles are congruent. We know KN is congruent to itself, and we know angle LKN is congruent to angle JKN because they are two right angles, but we do not know anything else. So remember we had options last lesson on whether a triangle can be congruent or is not necessarily. Same kind of concept here. Let's look at our questions. Can the hypotenuse leg congruence property be used? Well, do we have anything here that says the triangles are right triangles? No right triangle markers. We don't know. So we cannot use hypotenuse leg. We're not saying the triangles are not congruent, but I cannot use the hypotenuse leg property to prove it because nothing in either of those triangles shows me a right angle. Okay, let's look at the next triangle. Well, we do have right angles, but do we have anything showing that the hypotenuse and one leg are congruent? We do not. We do not know if those triangles are congruent. We know the right angles we know all the angles are congruent, but we cannot use hypotenuse leg. And that's what the question's asking. Okay, let's look at C. Okay, we have right angles, so they are definitely right triangles. One leg is 18, corresponding leg is 18. The hypotenuses are congruent. So yes, we can use the hypotenuse leg congruence property because we have the information on the hypotenuse and the information on the leg. Okay, let's look at this one. Oh, this is intriguing. Well, we know that the hypotenuse is congruent because they share them. We know it's a right triangle, but do we have any information on the leg, on either leg? We do not. So even though this is a right triangle, and we know that the hypotenuses in each triangle are congruent, we don't have any other information on either leg. So we cannot use the hypotenuse leg congruence property. I'm going to review this. In A, the question is not, are they congruent? The question is, can we use the hypotenuse leg congruence property? No, we cannot. These triangles are not right triangles that we can see. We have no proof they're right triangles. Question B, they are right triangles, but we have nothing telling us that the hypotenuse and leg are congruent to each other. The hypotenuse and leg in one triangle are congruent to each other. We have no information, so we cannot use that property. Question C, they are right triangles, and the hypotenuses and legs are congruent. So yes, we can use it. And question D, they are right triangles. The hypotenuses are congruent, but we have no information on the leg, so we cannot use it. All right. Now we're going to use another proof, going to do another proof, but use what we know about right triangles. So I'm going to write in a different color. Again, remember, state the givens. Step 1A, draw the picture. It will make everything so much easier. All right, so given WXZ and XYZ are right triangles. So one triangle, WXZ and triangle, YXZ are right triangles. That's a given. All right. There's nothing to mark because we already have the right angle there. Nothing to mark. Step 2. Statement 2. WZ is congruent to YZ. That's also given. Now I'm going to mark it. WZ is congruent to YZ. I have my 2 pieces of given information in there. Now if you look, YZ and WZ are the hypotenuses of the 2 triangles. Now go back to last lesson. We know that ZX or XZ, whichever way you want to call it, is congruent to itself because of the reflexive property. So I'm going to say XZ, and again, you can call it ZX, it's perfectly fine, is congruent to XZ reflexive property. And I'm going to mark it. Now, XZ is a leg in that right triangle. It happens to be the long leg. So you've got the hypotenuse and the leg of one right triangle congruent to the hypotenuse and the same leg in the other right triangle. So therefore, step 4, triangle WXZ is congruent to triangle YXZ HL congruency property. I really want you to pay attention to this, to see the order. Now guys, it's okay if you do my statement 2 before statement 1. That's perfectly fine. You're still getting the given information down. You don't have to do it in one exact order, but always put your given information down. It really helps you. All right, next page. All right, CPCTC. It's fun to say. I'm going to highlight it. And every letter has a specific meaning, and I'm going to write it down for you. All righty. corresponding ran out of room. Parts of congruent triangles, hard to do it this way, are congruent. I'm going to talk about that. We want to, when we use CPCTC, when we want to prove that angles or sides are congruent. When we use CPCTC after you prove the triangles are congruent. Now remember how we said in the first page on the first lesson, you needed to pay close attention to how you label your triangles. And when we mark them up, the congruent angle has to be matched with the congruent angle in the other triangle. Those parts are corresponding. I use that word. Now here, we're going to prove triangles are congruent. Then we're going to prove that unmarked sides or angles are congruent to each other. So let's walk through this. As I've said many times before, draw the figure. Alrighty, I'm going to start writing it. So, statement 1. Given angle PRQ is congruent to angle PRS. That's given. And actually at this point I want you to stop the video. I want you to complete the proof. Remember, the order of given statements is not important, but I want you to complete the proof. I highly recommend you draw the picture and mark it up as you go. But try to complete the proof and then start the video again and watch how I do it. All right, I'm going to mark PRQ congruent to PRS. All righty. Statement 2. Angle QPR is congruent to angle SPR. That's also given. QPR is congruent to SPR. Okay, I have those two angles are congruent. Now I have to think. Now my goal is to prove that PQ is congruent to PS. I'm going to highlight my goal. The goal is to prove PQ is congruent to PS. That's my goal. Alrighty? By pointing out my goal, it'll help me figure out where I'm going. So now, the triangles are attached. Reflexive property PR is congruent to PR because reflexive property, because a side is congruent to itself. The triangles share that side, therefore the side is congruent. Do I have 3 pieces of the triangle that are congruent? I do. I have an angle, a side between them, and then an angle. So I'm going to write down my triangle. Remember, you can call your write the first triangle any way you want, but the second triangle has to be lined up perfectly with it. I'm going to go with triangle RSP is congruent, sloppy symbol, to triangle RQP. Why? Angle, side, angle property. But I'm not done. I'm supposed to prove that PQ is congruent to PS. Side PQ is congruent to side PS. I do that by my last step. Now that I know my triangles are congruent, I can say CPCTC. Congruent, corresponding parts of congruent triangles are congruent. PQ corresponds to PS. The triangles are congruent because I proved it. Therefore, the sides are congruent. Alrighty, one more page. Now, hints on how to do a proof. Let's look at them. And we've talked about them, but I still want to cover them. Always draw the figure. Folks, if you don't draw the figure, you will lose track of things. You need to draw the figure. Label the given information on the figure. Remember I called that step 1A? Determine what else you need. And I love these questions. Do they share a side or an angle? If so, you can use a reflexive property. Do they have vertical angles? The bow ties, I'm going to write that. Bow ties, bow tie triangles. Did they give you right angles? If so, mark them as congruent and make sure you add their congruence in your proof. But you notice, oh, wait a minute. We didn't do that on the first proof. We didn't because the triangles were already set as right triangles. And we did not use, we used hypotenuse leg. We did not use angle side angle. So we're okay. But yes, I would do that. So once you've got your congruent triangles, you state they're congruent. And then sometimes you use CPCTC. But remember, you only use that if you have already proven your triangles are congruent. Let's work on this proof. I want you to stop the video. I want you to try this on your own. Keeping in mind, given information can be written in either order. And then I want you to start the video again and see if your proof matches mine or is close enough for mine. All right. So, statement. Given BC is congruent to DC. Given BC is congruent to DC. All right, angle BAC is congruent to angle DEC. Given BAC DEC. Notice how we never use the equal symbol? We don't use the equal symbol because we don't ever have angle measures. We just know they're congruent. We have no idea what the measure is, but it kind of doesn't matter. We just know they're congruent. Alrighty, I've got my two given pieces in. This is a bow tie. What do I have? I don't have any sides that are shared, but I do have a vertical angle. So I'm going to mark it. Now I'm going to call it angle DCE is congruent to angle BCA because of the, I was going to put reflexive, because of vertical angles. Now I want to point something out. I could have called the angle ECD. It's all right that I didn't. Remember, back to Unit 2, there are a couple of different names for angles. So if you called the angle ECD and ACB, you're right. You're still right. Mine is right and yours is right. It doesn't have to be perfect, just has to be mathematically sound. Alrighty. Do I have three pieces of congruency information? I do. I have a side, I have an angle, and I have another angle, and the side's not between the angles. So let's prove triangle ABC is congruent to triangle EDC, and we know that because angle, angle, side. The side's not between the two angles. So it's angle, angle, side. Property. You're going to be doing this now. You're going to be doing this on the summative. I'll help you where you need it. That's it.